All right, back with part two, picking up where we left off. To find the maximum height, we need to find the vertex. So we have our inverted parabola. What we're looking for, the maximum height, is this point right there. So we're going to use a specific formula based on our standard form equation. So we're going to use a formula to find the axis of symmetry. And that formula is x equals negative b over 2a. So in my equation for this problem, my a value is negative 16. My b value is 96. So c equals negative b, negative 96 over 2 times negative 16. 6 over negative 32. This works out very nicely to give me positive 3. So that means after 3 seconds, I will reach my maximum height. To find that height, I am going to substitute that value right back into the equation. So the height at 3 seconds so substituting 3 in for t, three squared is 9. 9 times 16 is 144, and that's going to be negative 96 times 3, 288 plus 6. Negative 144 plus 288 is positive 144. And 144 plus 6 is 50. So it will reach its maximum height of 150 feet after 3 seconds. So again, that's using that formula x equals negative b over 2a to find the x value of my vertex, the 3, and then taking that and plugging that back in and finding the y value, in this case 150. So as an ordered pair, it would be 3, 150. That would be my maximum height as a coordinate. And in context, that means that after 3 seconds, I will have reached a maximum height of 150 feet. All right, so moving on to F. So the visible features in standard form. Well, we know this C value is my y-intercept. And that's the ordered pair 0, c. And also don't forget what the A value tells us. If A is positive, the parabola is going to open up. And if A is negative, the parabola is going to open down. And it will also tell me whether it's stretched or if it has been shrunk vertically. So each formula tells a little something different. The vertex form obviously shows me the vertex. H comma K. It shows me the horizontal shift, which is H, the vertical shift, which is K, as well as the same thing the standard form told us about K in terms of a vertical stretch or shrink. So each form tells us a little something different. So in conjunction, they tell us a lot about what's actually going on in the situation. So we're going to go on to an example now. About how we graph. A lot of this is going to be repetitive as we've already done it. It is the same equation. So just looking at the graph, we know that A is negative 16, so it's going to open down. I know my y-intercept is going to be 6, so it'll have the coordinate 0, 6. And then can we factor define the zeros of the function? The zeros are the solutions, are the x-intercepts. They're all interchangeable in terms of words. It does not factor, as we saw before. When we did all the math out, we found out that t equaled negative 0.06 and 6.06. Those are the zeros of the functions where it crosses the x-axis. So these are the x-intercepts, and that would be negative 0.06 comma 0 and 6.06 comma 0. And then we found the vertex using x equals negative b over 2a. And that coordinate was 3 comma 150. So this is basically taking the information we got and now plotting it into a graph using the key features. So we got to scale this to get it up to 150. So I'm going to do each y by 10. And we'll keep each x by 1. And I'm only going to be concerned about this first quadrant. So I know my y-intercept is going to be right about there. The coordinate 0, 6. I know I have an x-intercept just about there at 6.06 comma 0. I know I have a maximum height at 150. 20, 30, 40, 50, 60, 70, 80, 90, 100. This goes to 130, obviously. So I'm going to put it right up here. And that point is 3 comma 150. And then I can sketch in my parabola, knowing that it's symmetrical. And keeping context of my function. So it's going to start at 0, 6, go all the way up to 150. At 3 seconds, it'll peak and then start coming down. And it will hit the ground after 6.06 seconds. So that just took everything we did and associated it. Out of context, a little easier. If we need to, again, we can use any of the methods, factoring, completing the square, quadratic formula. I gotta find that vertex first. So I'm going to use that formula, negative b over 2a. So negative b would be negative 5. 2 times 1/2 is going to be 1. So x equals negative 5 is the x coordinate of my vertex. Plug that back in. 1/2 of negative 5 squared, which is going to be 25, plus 5 times negative 5, which is going to be negative 25, plus 6. So 12.5 minus 25 plus 6, negative 12.5 plus 6, negative 6.5. So my vertex is negative 5, comma, negative 6.5. Because A is positive, I know it's going to open upwards. I know my y-intercept is going to be at 0, 6. Using the fact that parabolas are symmetrical, if I go 5 places to the right to get to my y-axis, going 5 places to the left will take me to negative 10. And because it's symmetrical, I should have a point at negative 10, comma 6, which will help define the shape of my parabola. And then when I sketch it in, I have my parabola. Now, if it specifically asks for the x-intercepts, I'm going to want to either factor, complete the square, or use quadratic function on this to get the exact x-intercepts. But when we're graphing a function that's quadratic, we just need 3 points. So if we have a vertex, a y-intercept, and then can use symmetry to find that third point, by all means, use those 3 points. If the y-intercept and the vertex are the same, that's when you're going to need to kind of expand to determine the shape of the graph and maybe some other points. And we will finish up with video 3 on this last question with context. Yep. And then you should be able to go through those packets that are hopefully home, as well as the Pumpkin Launcher performance task.